Hello, everybody, and welcome back to another visual pattern challenge. Today, we've got a strange one. We actually are starting with step two. Well, we're calling them stages in this one, and some of the stages or steps are blacked out, so we can't actually see what's happening in those stages. And your challenge is to determine how many of these blue squares are in the next stage, so stage 7. And then, if you can do that, can you figure out the number in stage 43? And can you write an equation that could be used to predict the number of squares in any stage at all? So that's the challenge. It's a difficult one today. If you'd like to accept it, pause the video and see what you can do. Okay, so this is a little funny. We're used to having a step one. That gives us a starting point always. We're going to have to figure out what step one probably was by analyzing what's going on here. And I think in this particular case, I'm going to start right away with an analysis of the numbers and see if that can give us any clues as to what's going on here, because some of this stuff is blocked out in between the steps. It's a little tough for me to wrap my head around visually what's happening in this pattern. So I'm going to make a chart here with the stage number and the number of blocks or squares. And actually, I'm going to put in some numbers that we don't have, and hopefully we can kind of fill in these blanks if we get some insight. So 1, 2, 3, 4, 5, 6, and actually I'm going to put 7 on here as well because that's the one we're shooting for finding the next step here or the next stage. Okay, so let's fill in the numbers that we do have. So here's stage 2, that's 5 and 3 is 8. We don't have stage 3. Stage 4, we've got that 5 at the top and then 9 more, so that's 14. And in stage 6, we've got that 5 at the top and then 3, 6, 9, 12, 15, and 5 is 20. Okay, so it seems to be growing at a pretty small rate. I'm guessing this might be linear, but let's actually take the difference, and we have to be careful here. We're going to take the difference between two steps. And if it's the same between these two steps and between these two steps, then we can divide that by 2 to get the difference between a single step. Let me show you how that works. So 14 minus 8 is 6. So that's the distance between 2 to 4, okay? If it's an equal amount each step, then they'd be changing by 3. From 2 to 3 would be 8 plus 3 is 11, and then 11 plus 3 would be 14. So if it's steady, that's what it would be. Let's see. If this is also 6, it's going to tell us that that's the case. 20 minus 14, it is 6. And I put that 20 down there for 7, and that's not where it belongs. It belongs there. So there we go. All right, so every 2 steps we go up by 6, and this is a constant, so it's happening at a steady rate. So really the change from step to step is half of that 6, 3 more to get to step 3, 8 plus 3 is 11, and then 3 more to get to 14 in step 4, and then step 5, 3 more would be 17, and then 3 more from 5 to 6 would be 17 to 20, and then step 7, you just add 3 more and you get 23. All right, I hope that made sense. I got a little messy here, a little scribbly, but basically we saw that between these 2 steps and these 2 steps, we're changing by 6. So we know then it's 2 steps of 3, and every step is changing by 3. And in fact, we can determine what step 1 actually is, right? So what do you add 3 to get 8? Well, that would be 5. So there are 5 blocks in step 1. And now that I see this with the numbers, the pattern, the visual pattern makes sense. In step 1, you start with these 5 blocks and then you add 3. And then this one in step 3 is going to have the 5 blocks and then 2 sets of 3. And then we've got 5 blocks and 3 sets of 3. This one's going to be 5 blocks and 4 sets of 3. And then we've got 5 blocks and 5 sets of 3, etc. Okay, so this is all making sense to me now. I hope it is to you too. We determined that stage 7 has 23 blocks in it. And I think we're pretty close to an equation because we've got our rate of change and it's a constant. So this is a linear equation and we can use this y equals mx plus b. And the m, the slope in the line, is going to be this rate of change between each step. So that's a 3. So y equals 3x plus something. And what is that going to be? And usually what we do is we go back to the first step to test it out. But be careful, this is not the first step. Our first step has 5 blocks in it. So step 1, or stage 1, is just going to look like that. And if we put y equals 3 times 1 here, that would be 3. And there are 5 blocks, so we'd need 2 more to get to 5. So our equation, our b in our equation, is going to be a positive 2, and our equation is y equals 3x plus 2. If we try that in a couple of stages here, let's put it in stage 4. Y equals 3 times 4 plus 2. That would be 12 plus 2, that's 14. That's how many we have in 4. How about in stage 6? Y equals 3 times 6 plus 2. 3 times 6 is 18, and 2 is 20. That's how many we have in stage 6. So this equation, y equals 3x plus 2, is going to work for us. And now determining how many in step 43, not too tough. We're just going to put 43 in for x. So y equals 3 times 43 plus 2. And 3 times 43, well, 3 times 40 is 120. 3 times 3 is 9, so 129 plus 2 is 131 blocks in stage 43. Well, how did that go for you? In the end, this was another linear pattern, and we've seen many of those before. It was just a little trickier getting there. So did you get 23 for stage 7? Did you come up with this equation? Let me know. Thanks, everybody.